Hi, I'm Tom from Siemens Digital Industry Software. In today's video, we're going to take a deep dive into one of the key themes from this year's NX premiere, AI-enabled and generative design. Artificial intelligence has been integrated with NX for years. Since 2019, the NX Adaptive User Interface has used AI and machine learning to boost productivity and tailor the NX experience to every user's needs. There's also a wide variety of powerful AI-enabled CAD tools to optimize designs, generate complex geometry, and simulate performance. Add-on modules such as Topology Optimization, Design Space Explorer, and Implicit modeling have all seen significant enhancements through NX's continuous release cycle. We'll show you these updates in action as we redesign this bracket that connects the forklift arms to the main body of this agricultural vehicle. Topology Optimization uses a finite element analysis of the design space and loading conditions to automatically compute an optimal design for a part. It helps you design right the first time and accelerates product development by providing optimal design concepts before detailed design begins. Here's how it works. First, we'll do some initial analysis in NX Motion. NX Motion lets you simulate and analyze the movements of parts and assemblies. This will help us set up the design space and conditions for topology optimization. We'll generate a motion envelope, which represents the space through which the forklift arms will move. And then we'll use the load transfer command to analyze and export the loads acting upon the mounting points for the arms during motion. This body is an extrusion of the existing bracket geometry. We'll open Topology Optimization and set it as the design space for a new study. Then, we're ready to refine the analysis with some constraints. Firstly, we'll set a maximum mass for the part and select the mounting points as fixed analysis constraints. Next, we can use the motion envelope from NX Motion as a construction body. Setting this to keep out ensures that the optimized geometry won't impede the movement of the forklift arms. The forces for the analysis load are derived from the NX Motion analysis too. We'll apply that to the relevant face where the bracket interacts with the forklift arms. The Subcase Manager lets you optimize for multiple scenarios and define different loads for each. We've set up subcases for the top and bottom positions of the forklift arms. Now, we're ready to begin the study. The Solve Progress Monitor is one new feature available in the June 2024 release of NX. As the study runs, a graph shows convergence towards the optimization objective and the geometry updates in real time in the graphics window. You could pause, restart, and stop the study at any time. We're happy with the convergence achieved, so we'll stop the study here. Topology Optimization generates the geometry as a mixed convergent body, ready for further refinement and detailed design. Complex organic geometry like this is well suited to advanced manufacturing techniques such as 5-axis milling, which you can now choose as a shape constraint option in Topology Optimization. For this part, however, our team has chosen additive manufacturing. This allows us to show you the generative modeling capabilities of the NX Implicit Modeling module. Implicit modeling allows you to create equation-driven and algorithmically generated structures beyond the capabilities of traditional CAD methods. We'll use it to further lightweight the component by filling the interior of the topology-optimized body with a gyroid structure. The first step is to use the shell command to hollow out the body. You can adjust the thickness of the shell wall and the smoothness of the inner surface. Here's a section view showing the inside of the shell. Now we'll fill the volume with an automatically generated gyroid structure. A gyroid is a type of TPMS, or triply periodic minimal surface structure, which allows us to remove mass from the volume without sacrificing performance. It's complex geometry that you can only practically achieve with implicit modeling. The Gyroid command gives you options for how to fill the volume, the size of each cell, and the thickness of the cell walls. As with the shell command, you can also adjust the smoothness as needed. NX shows you a preview straight away, so you can tweak the settings before you commit to the operation. Click OK, and NX will automatically generate all the geometry as specified. We can optimize the design further with another AI-enabled tool, Design Space Explorer. This add-on rapidly iterates through different design variables, simulating performance to recommend optimal configurations. We'll use it to lightweight the gyroid structure even more. First, we choose the TPMS thickness and cell size as our variables. The maximum and minimum values are based on the 3D printer's requirements for accurately printing self-supporting structures. To finish, we set a design objective to minimize the mass of the part. Once it's simulated each combination of design variables, NX shows us a table of all of the results with the optimum design configuration highlighted in green. The outcome is a 2.02mm larger cell size with 1.5mm thinner cell walls for a weight saving of 62 grams. If you'd like to learn more, we have a whole video just about Design Space Explorer. We'll put a link in the description below. Lattices are another type of complex geometry that you can generate in NX using the Lattice Designer add-on. And there are lots of new enhancements to show you from the June 2024 release. Lattice Designer gives you a range of lattice types to choose from. Voronoi lattices have randomly distributed pore sizes, which give them excellent energy absorption properties. You can now select one of 3 pore size distributions: uniform, variable, and Gaussian, before making further refinements. Select a body and you'll see a preview of the lattice structure that updates instantly as you adjust your settings. The Filter Lattice command is a useful tool for working with a lattice structure that you've already generated. You can now filter rods within a lattice by thickness or by ratio, and choose to apply filters either to the entire lattice or dangling rods only. The new Connect Dangling Rods command automatically connects the open ends of any dangling rods to help avoid print failures during additive manufacturing. You can choose a maximum rod length, maximum number of rods per connection, and use a closest or a random distribution. The Topology Optimization, Design Space Explorer, Implicit Modeling, and Lattice Designer add-on modules are all available through NX value-based licensing. And you can access the new enhancements that we've discussed today as soon as you update to the June 2024 version of NX. We'll see you in the next What's New in NX video, which will cover some exciting updates for NX's manufacturing planning capabilities.